Assalamu alaikum. My name is Mohammed Hanzim and I'm here today to present my final report on which actually discusses different minimizing methods for Tor. And I'm doing this on behalf of my group members, which are Shadil Hassan and Moaz Malik. So let's start with the presentation. So first of all, we're going to go through the abstract of this paper. So this paper is basically, the overview is that this paper is actually going to discuss the background of Tor services and its design and scope of the studies, the studies which we are going to do in this paper, and then the evaluation techniques and methods which are going to de-anonymize Tor, and then experimentation, and in the end, we're going to present the conclusion based on all the information which we're going to discuss in this paper. So first of all, let's look at introduction. So basically, Tor is an open source communication network, which was basically designed in the collaboration of United States government and DARPA. So Tor was actually designed to address the privacy concerns which users had and still have on internet while using internet. So basically, Tor uses an onion routing feature. This is first let's look at at the purpose of this whole research paper. So the purpose of this research paper is actually to present different methods which actually anonymize Tor and its services for us. So the scope is basically going to revolve around the on routing feature of the Tor network, and this is a feature which basically gives Tor its anonymizing powers, and then this paper is actually going to look into different aspects of Tor, which basically provides the user the aspect of anonymity. And this system is actually shaped toward a system of relays, which we are going to basically elaborate further in our design section of report. So the literature review basically, so in this section of the report, basically we actually describe the principle which Tor works on, and basically it has a system of relay nodes that actually acts as a proxy for the user, and it works in this way which is similar to the to the VPNs which we use in the modern world, but it is, you can say that it is much more, it is slightly more it offers a slightly more productive environment for the users, and basically this has a lot to do with the onion routing feature which we are going to discuss in the future. So there are certain anonymity aspects which the user has to keep in mind when he's using Tor. So as we have discussed before, the Tor is basically an open source network. So anyone can actually delve into the services of Tor by, by just downloading the Tor browser. So and it is quite easy to actually download Tor browser. It's free and anyone can actually use it. So that is not an issue. But there's certain things that the user has to keep in mind before using Tor services for anonymizing his identity. So their thing is that there are certain issues, not issues as such, but there's certain complexities that the network has, and this is actually introduced by the relay nodes and the system of encryption that the network is going to do. But the network is going to do most of the work on its own, so that's not an issue. But the choosing different relay nodes, allocating bandwidth when the inherent bandwidth is not at the required level, and condition control sometimes becomes issues in Tor networks. So the user needs to have certain background information regarding Tor before he actually uses it. So now there are different components that Tor has. There's a system of keys which we are going to discuss in design section, and these. But the only thing which I'm going to discuss here is that keys are important for decrypting and encrypting information in Tor network. So there are shells which are basically the main carriers of information through the relay node system, which is the basic feature of Tor. Then there is a circuit. This basically provides groups of relay nodes, and this is basically agreed upon when the connection is being made between the user and the server. So the design methodology. This is the one of the most important aspects of this whole paper. So the the main feature which actually Tor has, which is anonymity, and this is basically achieved through the system of onion routing. This is a very famous system, and we're going to actually look into the figure to actually get an idea of the whole process. So when the connection is being when the handshake is being done between the user and the server, there, there's certain things which are actually agreed upon. As I mentioned before, the first those things is a secret ID. Okay, that is going to be unique for every user and server in a connection. And after that, there are keys. The keys are actually also agreed upon, and those keys depend upon the number of nodes that are being reserved by the server for this whole communication. So each node is going to have its own set of its own key, basically. No, not a set, it's just a single key. So that key is going to basically perform the encryption and decryption at specific relay node. So the encryption is being done in ascending order. Like the first, second, and third nodes are going to basically perform encryption with their specific keys at uh, their specific and at the specific locations. So the data has been encrypted before it actually is propelled into the system, and when the data is at the point of return from the server side, it is actually decrypted in the reverse order, which means that the relay node which actually performed encryption at the end is going to basically perform the decryption in the start with, and this is also going to be approved by this key at the specific location, which was actually agreed upon in the beginning by the client and server side. So this is the basically an onion routing feature, and this is actually called onion routing because it in the process of encryption we actually introduce a layer to the data which we are going trying to pass through the Tor network, and during the decryption, that layer is peeled off in the reverse order. So this is the actually the main feature from which the onion routing gets its name. This is a this is basically the important aspect of Tor. So now we're going to look into the evaluation analysis. So we're going to basically discuss different methods which we actually incorporated in our research paper for de-anonymizing Tor. And the first method is a Bitcoin transaction analysis. So this is a very straightforward method, as it basically revolves around analyzing the user activities on the public domain, and then trying to interconnect it with his activities on the private domain, which is Tor. So let's assume that we have a user who is actually asking for which is actually asking other users on internet to basically perform Bitcoin transactions to his account, and once those transactions are made, the user uh, fearing the privacy actually decides to uh, perform the transaction of all those amounts to his domain on private network like Tor, through Tor. So basically, the underlying factor here is that there is another person who is actually trying to de-anonymize the person activities, and he's basically going to he would be able to actually pinpoint the user identity through his analysis of the user's public activities, and then he will be able to relate it to the his activities on private domain. And in that purpose he would be and through this whole process he would be able to actually pinpoint or identify the user who is actually using the Tor services. So this was basically the whole concept of the transaction analysis, Bitcoin transaction analysis. Then there is some other methods. There's the sniper attack method, which this is basically not a de-anonymizing method. It's basically shows that we can actually present different delays into the into the network which Tor uses for for anonymizing the user identity. So basically, we're going to actually decide on a target node which we are actually going to kill during the whole communication process. Normally, it is an entry node, and it is basically manipulated by shunning an information which is being processed, which is basically being redirected from the server side to the client. And once it shuns the information that is being sent, the network is going to actually notify the server that there is a degenerate node in this whole system, and that and the server will actually then try to replace that node with another relay node. So this is going to actually introduce different delaying uh, tactics into this whole system. And after that, there is padding cell method, which basically makes use of the concept of rendezvous circuits, and this is basically going to make use of special signature, which basically is going to be incorporated into traffic, and through this signature we will be able to carry out user identity analysis. Then there is the website fingerprinting attack. This basically is also a delaying tactic, and in this tactic, which we are first of all trying to identify different positions where we are going to perform the delay of information, and during their delay, actually going to basically perform the analysis of the HTTP request that is being sent by the user. And another thing the thing which is actually worth mentioning here, that there would be actually a node which would be our node in this whole relay system, and that node is going to be basically we perform the delaying tactic, and then the delaying analysis of the user, and from which we would be able to identify who is actually using the our services. So in experimentation, we have we have actually used Tor browser on Windows, and we have configured the Tor details file, and then we have initiated communication by specifying the port and contact ID, and then when the whole connection was being carried out, there was actually some analysis from which we did from the log file, and in this file, the contact ID which we initiated conversation with the server with actually was changed, and this was due to the relay node system, that the user ID was actually changed and manipulated by the Tor system to basically provide the privacy to face it to our whole conversation. So this was the experimentation, and the conclusion would be that well, Tor is actually a very suitable proposition if you're trying to basically look for a privacy. Basically, if you're trying to address your privacy concerns, and with this onion routing feature, it is a very, you can say, a safe